So you probably hated the video that I left you for you Wednesday. So this is your easy one, calculus. This is writing equations of cosine graphs. You already know what the graph of y equals sine of x looks like. But cosine is pretty similar, and it's about the unit circle. They're actually really close cousins to each other. They use the same key points because they have the same period. And if you think about the unit circle, same intervals of pi. So I'm just going to jot those intervals of pi down. I'm going to plot my points. Now, when you think about the unit circle, remember cosine is the x value of the coordinate. Cosine of 0 is 1. When you're over here on the unit circle, the x value is -1. So at 0, cosine actually starts up high. Remember, sine started right at the origin because the sine of 0 was 0. And if you're as high as you get, you have no choice but to start falling. Cosine of pi over 2 is 0. Cosine of pi is -1. 3 pi over 2, x is 0 again. 2 pi, it's come full circle. And that pattern continues forever and ever. We call these periodic functions because they cycle through the same period their entire life. It's all they do. They go up, they go down, they go up, they go down for all their existence. Now, the other day in class, Tanner asked how I know the difference between sine and cosine, and I told him that I would explain their relationship. And Tanner's in here now, but he's probably not listening.
I'm listening.
Oh, are you really? Oh, okay. I don't know if you can see any of this. You might have to watch the video. But you have the identity that says the cosine of an angle is the sine of 90 or pi over 2. Take away that angle. So what I'm going to do is I'm going to overlay the graph of sine on this function. And it would start here. I'm going to dash it out. It would rise to 1. And then it would start its journey downhill. And then it would go back up. It's not perfect because I'm dashing instead of drawing. Surely you kind of see that you could take this graph of sine and shift it 90 degrees and it would line up with cosine. And that's kind of the deal. Cosine is nothing more than a phase shift of sine. Cosine is a 90 degree or pi over 2 phase shift of the sine function. That's the relationship between them. The truth is, it doesn't matter if you graph a sine or cosine function, they're the same thing. You just have to include a phase shift. In fact, nobody ever really writes cosine functions. TI-84, I don't think the TI-84 is capable of fitting to a sine function. I don't think it's capable of fitting to a cosine function because there's no point in it. They're the same graph, just phase shifted. We have the same form as we did the other day. A is amplitude. If you think about cosine shares the same period as sine. So to find b, we use the same idea that period is 2 pi over b. C is still found by doing C. Phase shift is, and we know that Carolyn knows this one by heart, phase shift is equal to -c over b. Then, of course, d is your vertical shift. I got about 10 minutes here, and I don't want to bore you with the really easy ones because they're boring. This one's kind of boring, but It's got some more going on than the first example. The first example didn't even have a vertical shift. This one does. We are doing nothing but graphs of cosine in this function, okay? The very first thing I would do, and of course I know you're doing this on your phones, your PCs, but you need to imagine this horizontal line here. You do, because that tells you your vertical shift. You are shifted up 5, and by drawing in that vertical line, you gain access to the amplitude, and you may not see that if you don't draw it in or imagine it's there. Looks like the amplitude is 2. The period needs to be correctly identified, and I just picked 2 nice points from there to there. Might be hard for you to see on whatever you're looking at, but that goes from negative 2 pi to 2 pi. So I also know my period is 4 pi. Now by this point in our life, we already know what value of b creates that. That makes b a half. If it doesn't, you need to sit down, you need to work out the formulas a couple times till you get it. That makes b a half. I don't see a phase shift. I don't see that it's been scooted left or right. I mean, if I kind of overlay this, if I think about this being kind of like mom, cosine started high just like it does here, so there's no point in looking for a phase shift. It doesn't exist. So C is 0, and D is nothing more than 5. So it's a pretty equation to write, pretty easy equation to write. Simply f of x equals twice the cosine of a half x, add 5. That one's kind of easy. Wasn't bad. They don't really get difficult until there's a phase shift, and I know some kids have a hard time seeing there is a phase shift. So that one shouldn't kill you. And most of these are really, really easy. I think just knowing how to be able to do this will get you into the 80s. What I did. There's absolutely nothing interesting about that one. There's absolutely nothing interesting about that one. There is something interesting about this one. Actually is something interesting about this one. Remember that cosine, if you look at mom, cosine starts high on its origin and falls. It starts high. I don't see that happening at the origin. It's not there. So this one's been phase shifted. I always just play around with quadrant 1, but there's nothing stopping you from playing around with quadrant 2. But I'm going to draw in a vertical line here. That's my phase shift. I can see it now. This thing has been shifted to the right pi. So my phase shift is equal to pi. Now this one doesn't have a vertical shift. There is no vertical shift. If we take a glance at the period, well, the period's a little bit different, isn't it? Of course, I kind of drew over it, but it goes from negative pi over 2 to pi. So the period is 3 pi over 2. And we'll just figure out what b is real quick if you don't remember it. 3 pi over 2 must equal 2 pi over b. If you cross multiply, you'll have 3 pi b equals 4 pi. 3 pi b equals 4 pi. So b is 4/3. And that's needed. You need that. You need to get b before you can get c. It's kind of like alphabetical order. Since your phase shift is pi, pi must equal negative c over b, 4/3. You kind of cross multiply here too. 4/3 pi equals negative c. So c is a negative 4/3 of pi. And I think we have all the stuff we need. We have a, we have b, we have c. D is 0 because there's no vertical shift. So here's my function. F of x is a. I didn't even talk about a, did I? Thing rises to 4. Here's your amplitude. 4 cosines. 4/3 x. Take away 4/3 thirds of pi. And these pieces don't always match, so don't assume that there's a shortcut here. They do not always match. Of course, plus 0. I'm going to do one more with you before the bell rings here. It'll be the last video I record for the week. This one's got two shifts going on. Again, I like to pick on quadrant 1. But I noticed that that high point is right there. And there are other ways of writing this. You can actually also write these as reflections where A is negative, but you don't have to. I like to keep A positive. So here's kind of my origin of the child right there. I can glance at that, and the amplitude is 1. See, it goes 1, 2, 3, 4. Every 2 blocks is 1, so the amplitude is 1. Period goes from pi to 5 pi. Period is actually 4 pi, which means that B is a half. So I have A, I have B. I need to get C. The phase shift is that we took mom and we shifted it to the right, 3 pi. So 3 pi must equal negative C over B. And we'll cross multiply. 3 pi over 2 is a negative C. So C is a negative 3 pi over 2. And we also have this vertical shift. This thing was shifted up 5 units. Shifted up 5 units. And by the way, if I'm going too fast, rewind it, hit the pause button. Shift it up 5. So D is 5 units. And there's your 4 letters of the alphabet. F of x is 1 cosine of 1/2 x minus 3 pi over 2 plus 5. So this is the easier lesson. Enjoy it. That covers ixlC13. Tomorrow will be Friday for y'all. Tomorrow and Friday is a work day.